Hello everyone. So today we are going to see another lead code hard level questions, but this will be DFS questions only, but with little bit of DSU also involved. Okay, so you need to have some graph concepts also ready with you before solving this. It wouldn't be much, but I would say it is little bit hard level of DSU questions. Okay, so the first question is, let's just go to the question and read the question first. Okay, this is the lead code hard. Question says Alice and Bob have an undirected graph of n nodes and three types of edges. Type 1 can be traversed by Alice only, type 2 can be traversed by Bob only, and type 3 can be traversed by both Alice and Bob. Both can traverse. So you are given an array edges where edges I is equal to type I, ui, vi. Represents a bidirectional edge of type I between nodes u and v. Find the maximum number of edges you can remove so that after removing the edges, the graph can still be fully traversed by both Alice and Bob. And the graph is fully traversed by Alice and Bob if starting from any node they can reach all other nodes. And you need to return the maximum number of edges you can remove or minus 1 if Alice and Bob cannot fully traverse the graph. So here you could see that between 1 and 2 Alice can traverse. Alice can traverse from 2 to 3, Alice can traverse from 3 to 4 because it's green, so both can traverse. Similarly, Bob can traverse from 1 to 2, 1 to 3, 3 to 4. Okay. So starting from any node, it should go to any node. So again, 2 to 4 is not needed because this can be traversed. Okay. So this is not needed. And similarly for Bob, we don't, so this is if we remove the two edges. So 1, 1, 2. Okay. Even this is not needed for Alice. 1, 1, 2. Because Alice can go from, let's say, 4 to 3, 3 to 2. And oh, Alice cannot. Type 3 is blue colored. Sorry. My bad, my bad. Okay. Type 1 is only traversed by Alice. So Alice, we can remove 2 to 4, let's say. Okay. So Alice can traverse from 1 to 2, 1 to 3, and no, we can remove 1 to 2. Yes, blue is traversed by both. So we can remove the red one from here. So Alice can traverse 1 to 3, which is the red one, 1 to 2, 2 to 3, and 2 to 4 also. Okay. But we even, and for Bob, it's green colored. Okay. So Bob can traverse. For Bob, it's like, let's say it start from 1. Then from 1, it can go to 2. From 2, it can go to 4. And from 1, it can go to 3 also. So we don't need this 3 to 4 wala edge because we can remove that Bob's edge. So these two edges we can remove and we are still good with this. So these are the number of edges you need to remove. Now, how we will solve this question? Now, I would like to think you a little bit and then come to the solution. Okay, so the question has like type, UI, and VI. So it's like a type I, UI, VI. So if type is 3, that means both Alice and Bob can traverse this edge. If type is 1, then only Alice can traverse this edge. And if type is 2, then only Bob can traverse this edge. Now, what we can do is we can create two DSU components, one for Alice, one for Bob. For Alice, we will mark all edges which Alice can traverse here, and we will make a group of tree because DSU always makes a group of tree. And for Bob also, we will create one group of tree. Now there should only be one group of tree, and its size should be equal to n number of edges. And the extra ones we need to remove. Okay, so first our priority should be to take the type 3 edge, of course, because that will cover both of them. So we'll take first type 3 edge. If already between UI and VI their parents are same, if their parents are already same, that means they are connected, so we can remove this edge. Okay, for type 3 edge, if for Alice DSU graph both of these parents are same and for Bob DSU's graph also both this are same, then we can remove this particular edge, one edge. Okay, for type 1 we just need to check the Alice parent, and for type 2 we just need to check the Bob's parent of U and V. If those are same, that means we can remove those edges. Okay, and let's just quickly solve this so that you can get a better idea. I will just paste the DSU over here, class. Okay, So I have my class DSU, and of course this will be starting from 1 to n, so we'll have a DSU of size n plus 1s. Okay, so L is n plus 1 and Bob also n plus 1. Okay, now we will go into each of this. We'll have a L is 0, Bob 0, and total number of edges to remove will be 0. Okay, now why I have taken A and B, you will get to know in a short period. So for int I0, I less than edges dot size I plus plus. If your edges of I0 is equal to 3, that means this is the type 3 edge. Okay, type 3 edge, check for both Alice and Bob. So if Alice dot find parent of what, edges I1 equal to I2, then I will make A as 1. Okay, if Bob dot find parent of I1 is equal to Bob dot find parent of I2, then I'll make my B as 1. And after entering into this, I'll of course make A as 0 and B as 0. Okay, so now if A is 1 and B is 1, that means both Alice and Bob I am able to delete. Their parents are same, means I can delete that. It's already under one tree. Then I will do my count plus plus. Okay, now similarly you need to do for type 1 and type 2. So if edges I0 is equal to 1, then you only need to check for Alice. So if Alice dot find parent of edges I1 equal to Alice dot find parent edges of I2, then count plus plus. And similar way you need to do for Bob. Okay, I can have it here also, like no need of this. So else if edges of I0 is equal to 2, and if these are related to Bob, okay, we missed one point. Did you get that? What? If parents are not same, if parents are not same, then we need to union also, right? Then Bob dot union are I1 with I2, and similarly here else Alice dot union I1 with I2, and here also, like, so if Alice dot find parent, then A is equal to 1. If Bob dot find parent, then if A is equal to 1 and B is equal to 1, then we can just do count plus plus. Else we need to union both. So Alice dot union I1 with I2 and Bob dot union I1 with I2. And we just need to check if Alice dot get size, Alice dot find parent of 1. We'll find the parent of 1 and we will do the get size. If that is not equal to n, we'll return minus 1. Similarly, if Bob dot get size of, we'll just do for any one node, Bob dot find parent of 1 not equal to n, return minus 1. Otherwise, we'll return count. This is the number of edges we need to remove from the total given edges, right? There's some error. Oh, there is no get size here. Int get size int n, return size of n. Cool. Okay. There is another question which I will just give you a heads up on, and then you have to solve it by yourself. So the question says, you are given a string S. I will put all this question link in the description, so don't worry. And an array pair of indices in the string pairs, where pairs of I is equal to a comma b, indicates two indices, okay, of the string. You can swap the characters at any pair of indices in the given pairs any number of times, and you have to return the lexicographically smallest string S that can be changed to after using the swaps. So the example is given, S is DCAB, and these are the pairs. So 0 and 3 is one group, 1 and 2 is another group. Now these are like two different groups of the DSU. Okay, there is no common point. So of course we can swap 0 with 3, so D with B, and B of course should come first, so it will be BCAD. And then for 1 2 it should be CA, so A should come first, then C. Okay, so ideally your string should become BACD, and that's the correct. Cool. Now same string, but pairs are given like 0 3 1 2 0 2. Okay, let's just come over here. Okay, you're given the same string S as DCAB, but the pairs given to you is 0 3 um sorry 0 3 1 2 0 2. Okay, 0 3 1 2 and 0 2. So that means 0 is connected to 3, 1 is connected to 2, but then 0 is connected to 2. So in a way all is one group only. So this means all this 0 to 3 are in a one group only. So of course we can sort this in itself. So A B C D is the only your answer, because you can swap any with the any of this. Okay, and that's where you'll get the sorted string. So now what we will do, I'll give you the hint. You'll create a DSU. Okay, and you will create all different trees, all different disconnected sets which you can form. So let's say 0 3 is one, 1 2 is another one. So there are two different this 0 and 3. You will collect all the characters of this tree together. So here only 0 and 3, so D and B will be connected together. Okay, and for 1 2 it will be B and C, let's say. Okay, A and C, A and C. Now what you will do, you will make this as the sorted strings. So you will make this BD, and you will make this as AC. And now you will also store the indices. Okay, and that also you will store in the sorted form only. So 0 and 3, 1 and 2. So now at 0 you will put B, at 3 you will put D, at 1 you will put A, and at 2 you will put C. So ideally what you should need to do is you will make a DSU. You'll union all these pairs given to you. Okay, this will give you all different disconnected sets, whatever is possible. Now you will make two maps. One map is for parent of that tree with the vector of characters that will store all the characters. Okay, this is one of the map. And you'll make another map which has also a parent of that tree and vector of int, and this will store all the indices, corresponding indices. Now you'll sort this string, sort these indices, and store at this particular indices this characters. Okay, and you'll get the sorted string. I hope you get my point. Please try to solve this. And there is another question also which you can solve with the DFS also and with the DSU also, in both the ways, which is evaluate division, which too I'll put in the description. So please go through it and solve it. Okay, one question which we have solved is the Leetcode hard question. Please solve that too also. So if you have learned a lot out of this, do like, share and subscribe. In the last video of this DSU topic, DSU playlist, I will be covering mainly one or two questions mostly. That will also be very hard level questions of the DSU, and then we will stop our DSU playlist over here. Okay, I hope you have learned a lot about DSU, how the questions will come, how you will apply DSU on top of it. If you have any doubt, please comment in the video itself. Thank you. Stay tuned, stay safe. Bye bye.